Hello and welcome to my very first YouTube video. Today we will talk about this. This is a microcontroller that is also Arduino compatible. And what we will do with it is that we will add a little sensor that will both measure the humidity and the temperature. And we will then connect it to Salesforce, where we will do some magic. But first, let's roll the intro. So why am I doing this? Well, say hello to Shiro, our pet chameleon. So Shiro is super sensitive when it comes to the humidity and the temperature of his surrounding. So I will basically use this to keep track of his health. Also, I created this little app some time ago that me and my girlfriend uses every single day to basically log how many crickets he has eaten every day. And based on that, the app tells us whose turn it is to feed him next, and the average, and more. And you see here that I made 2 fields visible here in the app, just waiting to get some readings in from the actual hardware. But of course, it's more complicated than that under the hood. So I'm not only storing 2 fields, I also store enough so we can do some reporting back in time. But enough about Salesforce talk for now. We will dig into that more later. First, I want to have a look at the hardware itself and how to actually assemble the hardware. So let's have a look. There are so many combinations of hardware you can choose from, but luckily for you, I've done the research. So as long as you go with the recommendations I will give you here, then you will be able to follow along you too. I decided on a board that is based on the chip called ESP8266 because it's Arduino compatible and it also has built-in Wi-Fi. At the time, I didn't know how much storage I would need because I hadn't written any code yet, so I went with one with much storage. Also, it was important that I chose one with USB because of the simplicity of giving it power and also to program from the USB port. I also saw that for some of the boards you could add an external antenna, and I wanted that because I wanted the range also to be a bit overkill, because why not? For the sensor, I went with one that I found in a local store, a very basic one. You will find links in the description for everything, of course. Oh, here's the price, by the way. So very affordable stuff, definitely. Now let's put everything together. So here's all the things that we need. The fan here to the right is something I've made myself that will keep me from inhaling the smoke. So for the board that I used, there's an option to use an external antenna. For that to work, I had to move this tiny resistor here to a new place. Fortunately, I had a hot air soldering station, so I simply heated the components to 300 degrees and simply just lifted off. Then I added some solder to the new points, and then it was time to heat up the solder again and put the resistor back. Now it's time to attach some wires to the board. So yellow is data, black is ground, and red is power. Remember that. So strip the wires and solder the wires to the board as shown here. Now I'm going to use a shrink tube. And how it works is that if you apply heat to this tube, then it will shrink down and hold tight on whatever inside. So it's great for holding cables together and to isolate. So I have now measured the cables and put them in a shrink tube that, when it's against the board, is just a bit shorter than the cables, like this. And it's time to attach the wires to the sensor. First, measure how long the remainder of the shrink tube should be to fully cover the wire. Now, slide the shrink tube over the cable that goes to the board. We will slide this over back towards the sensor after the wires have been connected, so just leave it here hanging. So we'll now need some smaller shrink tube that will go over each smaller cable to make sure they won't touch each other and cause some kind of short. Now we're almost there. It's time to connect the cables together. So if you want to know how to solder two wires together with the same standard as NASA, I'll leave a link below. Now with all the three cables connected, slide the smaller shrink tubes in place and heat them up to make them shrink. So now it's time to slide the larger heat shrink all the way to the sensor until it stops and make it shrink. Nice. We're almost done here. So now I can attach an antenna and everything should just work fine. As a finishing step though, I'll also fill the sensor here with some hot glue to make it more rigid. Great, we have assembled the device. Now we somehow need to make sure that it connects to my Wi-Fi, then connects directly to my Salesforce org, and then stores some data. So the next thing we will talk about is the data architecture, how we're storing all of that data. Let's log in. So I'm in Schema Builder in Setup, and I want to introduce three objects to you. First of all, I want to introduce you to IoT device. So this is a very simple object. We track the temperature, the humidity, and also a device ID, which is an external ID, which is very important later on. For some of you, this would actually be enough. So maybe you only want to track the current temperature and humidity of a specific device. Then this is all you need, really. But I have more requirements than that. I need to measure the maximum, the minimum, the average humidity and temperature per day 3 months back in time. For that, this simple object is not sufficient. So let me introduce the next object to you, which is the IoT reading. So this is actually the record that our IoT device will create in our org. What we will do is every minute the IoT device will actually create this record. So it will store the temperature, the humidity, and also there's a lookup relation or a master detail relation to the IoT device itself. So kind of straightforward, you would think. But this that I'm working in is a developer edition org, which has some limitations. So we only have 3 megabytes of storage. With this particular solution, we would actually eat up all of the storage in less than 2 days. So we need to think of a better solution to cover all of the requirements. And that leads us to the last object, which is the IoT daily summary. The idea behind this object is that here we actually look at all of the readings from the day before, and then we calculate per IoT device and populate the average, the maximum, the minimum humidity and temperature in this object. And once we have created that object, we no longer need the IoT reading records, so we simply just delete them. And then we only store the IoT daily summary. In a way, we are being forced into optimizing the data architecture like this. But it comes with lots of benefits. If we had unlimited data, if we didn't need this IoT daily summary, if we only had IoT readings, we could still live up to all of the requirements. But to look back 3 months, we would actually need to query 129,000 records, something like that, to be able to come up with the average per day during those 3 months. With our solution, with the IoT daily summary, we only need to query 90 records. Because of that, our solution is faster and comes with better user experience. That's the end of part 1 in this playlist. Be sure to subscribe and hit the bell icon to be notified when part 2 is out. It also helps me out a lot. In the next part, we will talk about the logic and the integration behind this solution, so you definitely don't want to miss that one. Also, feedback and sharing is super important to me, so be sure to share this video and tell me what you liked about it or what you may have done differently. I want to learn from you too. See you in the next one.